Our last example on synthetic division goes back to just simply doing a division. We have a polynomial to the fourth order, and we're supposed to divide it by x plus 1. So how do we do that? Well, it looks like we're having some missing terms. The x squared term is missing. The x to the first power is missing. So we're going to insert those terms with a 0 coefficient. So using synthetic division, we put down the coefficients. We put down 3, minus 3, and then for the 2 that are missing, we plug in a 0, and then finally we have the 2 at the end. So this represents the 3x to the fourth minus 3x cubed plus 0x squared plus 0x to the first power, and then the constant plus 2. And then here we plug in minus 1 because we have x plus 1, so we take the negative of that number and put it in here. And then we put down the line, drop down the first number, and we're on our way. So 3 times negative 1 is negative 3. Add them together, you get negative 6. Negative 6 times negative 1 is a positive 6. 6 added to 0 is 6. 6 times the negative 1 is minus 6. Added together, you get the minus 6. And minus 6 times the minus 1 gives you a positive 6. Added together, you get 8. So we do have a remainder. And so what that means is that when we divide this by this, we get, and let me write it out. It might be easier to write it like this. So 3x to the fourth minus 3x cubed plus 2 divided by x plus 1 now becomes, here are the coefficients. We have 3x cubed minus 6x squared plus 6x to the first power minus 6, and then the remainder plus 8 over x plus 1. And that's how you use synthetic division to divide a polynomial that has missing terms by that binomial x plus 1.